Hello human beings, today I will be teaching you some science. And I've already actually made this video a couple times before, but my microphone didn't work, so I'm redoing it. But anyway, I'm going to tell you something. You, if you aren't blind, which you probably aren't, have technically seen back in time. Now, you may not believe me now, but let me go on. So anyway, first of all, light, I just want everyone to know light is not constant. From the sun to your eyes or to the earth, it takes approximately 8 minutes for it to come from the sun to the earth. So, that means when you look up at the sun, you're seeing things 8 minutes late. See? That's pretty simple. But I'm going to go a bit further than that. So, let's just quickly grasp how light works. Let's just say you are this person. I'm just going to draw a person real quick. You may not look like this, but this is just like a quick sketch. So this is you. And now let's just imagine this is a lamp. This is a nice little lamp that's putting off a light source. And this is a wall. Now light will go 360 degrees. So from here, it's going to go in every single direction that it can other than this side. So just fill in the entire... Okay, I'm just going to draw a triangle real quick. So fill in this entire triangle, and that's how much the light covers. So the way it works is either you can be facing the lamp and you'll just directly see the light because your eyes are in an area of the lamp light. And how will you see this wall, you may ask? Because in the dark, unless you have night vision, you can't see that wall. Let's just imagine it's really dark. You can't see the wall in the dark. But after you turn on the light will bounce off the wall and come into your eyes. And that's how it works. Light bounces off the objects that you're trying to see, and it comes to your eyes because again, light will go in 360 degree angle from where it is. So if light is here, then 360 goes in every single direction, and if it goes in this direction, it bounces back. So just remember that that's how light works. It bounces off objects, and that light comes to your eyes, and now you can see the object it bounced off. So that's pretty much the premise of the entire thing. You just light is practically just simply a thing that comes from a light source, and if it bounces off objects, you can see them. So that's pretty much it. Every time you look at, let's just say this screen that you're watching this YouTube video on, that screen is sending you light. But in reality, it takes time for that screen, the light from the screen that you're watching it on, to come to your eyes. So, for example, you are watching this YouTube video with an incredibly short amount of delay. I think, I may be wrong, I may have got some digits mixed up. Light comes out around 300,000 million miles per second, kilometers per second. I don't know, really fast. So it would not really make a difference. It would not really make that big of a difference. You wouldn't notice it at all. But it's still there. You are technically still watching this YouTube video with an incredibly short delay. And I feel like that's pretty interesting. That's, for example, the James Webb Telescope. James Webb Telescope. So that telescope is a you might have heard of it. It's recently created telescope, and it's the best telescope humanity has made yet, and it's really good. So it's not only looking very, very far, it's looking very back in time. So some star, if you look up a picture that was taken from the James Webb Telescope, you might see some stars that have actually already died, like exploded. And that gives me to my third example. You know how this sun would explode in like some like 10-ish billion years or 7, I don't know, like it'll explode in some amount of billion years. Well, when it does explode, you'll still see it for another 8 minutes. So you'll still be able to see the sun, although it's already exploded. I mean, you'd already be dead, but theoretically.